Hello everyone, we are from US Robotics and our problem statement for Smart India Hackathon 2025 is disaster response drone for remote areas and our problem statement ID is 25047. So now let's focus on problem. Let's understand the problem in a better way. So as we all know that natural calamities and disasters, it's a really common issue nowadays, and also people goes missing and they lost their lives in thousands. This number is not even in hundreds, it's in thousands. So natural calamities and disasters, it's a really big issue nowadays. For example, in Punjab, Punjab is full of floods, and also landslide is really common in Uttar Pradesh and Uttarakhand, right? So it blocks roads, it blocks the regions and terrain regions, and people gets blocked and tripped there, right? So uh, so that's our problem. As we can see in the image, for understanding better way, due to heavy flooding, this area has been landslided, right? So in this landslided area, the people are caught and they're trapped here. So in normal scenario, what happens that a rescue team comes and they just go for identifying that where are the people and what help they need, and they try to establish the communication. And this, of course, this takes a lot of time. So what if instead of this, we just make a disaster response drone which is particularly made for remote areas like this, as I've discussed in image. And for areas like this, the drone which will provide the medical aid, which will provide food, which will establish the communication, which will identify that how many people are there, how many people are trapped, how many people are alive, dead. And with this solution, the productivity will increase, the responsive time will definitely increase. So now coming to the topic of hardware, like technical approach, coming to the topic of hardware, of course the basic components we'll be using are flight control, which is the main CPU unit, then electronic speed controllers, which are for controlling the speeds, then brushless motors, which are not of too much RPM, not of too much torque, which are same in torque and RPM, and also frames. Coming to the frame topic, the frames should be scalable too. It means they are of such model that they can be made ready for industrial levels. Means they are scalable. We will come to this topic again also. And mainly for location identification, we'll be using GPS models. For example, after doing a surveillance round, the GPS coordinates will be set in the flight controller, and by this, by GPS coordinates, the location will be particularly set, which will be more precise, right? And also for visibility, this is our main key factor. We will be using 4K web camera. So by using 4K webcam, the visibility, the quality of the video and photos, which will be really nice and of high quality. What happens by this, that by integrating it with AI and machine learning, and also by using 4K web camera, if we integrate all of these things together, what happens that the quality of the photos and videos get much higher, and we can identify the what exactly the problem that the people are in, and what help they exactly need. For example, by using high quality cameras such as 4K web camera, we can identify that what help they need, right? So they need food, they need emergency, for example, or they just need communication, right? So by using 4K web camera, many of the problems can be solved. And also for integrating it with AI, which is in problems 2.2. So for integrating it with AI, we'll be using Raspberry Pi, and Raspberry Pi is actually enough. By using Python in this Raspberry Pi, we can integrate it with AI, and also we can train it for many purposes, right? And also we can add sensors too. For example, uh, in Arduino, we can, for example, we can add Arduino, and also by coding it with C++ language, we can add sensors and everything, and we can integrate all of them together with AI, also with software also. And for simulation training, we can use ArduPilot, which is used for simulation training, and which we can make it as perfect as possible. Now coming to the topic of feasibility and viability. So firstly, why it is feasible? So why it is feasible, first thing is that we are using off-the-shelf hardware. It means we are not using way too much innovative software of innovative hardware, that there is no need of innovation in hardware. We will be using already existing purposes, such as frames, motors, which are many big players, many big companies which are there, which use them and which produce them. So we'll be directly using them, and there is no need of some particular frames and particular motors. By this, what happens that our costing also, and our innovation and research and development team also uh, get saved, and also by using off-the-shelf hardware, it's really feasible. And also we'll be using open source softwares. It means like ArduPilot, as I've discussed earlier. By using these open source softwares like ArduPilot, the simulation training will be done in smoothly, and also they are not paid, so it will be done with a less cost too, so it will be cost effective too. And also for training the AI, we'll be using prone AI libraries. It means there is no need of making a new AI and also training it. So by using OpenCV and Python for navigation in Raspberry Pi, by it means by using these proven libraries, it will be easy and feasible for us also and for everyone to make it feasibility. That's why this point is in this slide. And also it's scalable design. As I've discussed earlier, by using frames like this in this image, by using frames like this, it is scalable also, and it is modular also. It means they can be made ready for industry level too, so they can be made thousands of such exact same model, which it means it's scalable. It has scalable design too. And also coming to topic of viability, why it is viable, that what's the need, right? So first one is high demand. We all know that in all of such cases there is high demand of such kind of vehicles which can be really responsive, really productive, right? So, and especially drones. So there is high demand of drones in government agencies and many NGOs, that they need such kind of vehicles. So yeah, we made it, and also it is viable, right? So now coming to the cost effectiveness, which we'll see in depth later on also, that it is cheaper also and faster also if we compare to chopper, which is traditionally used. If we compare it with the chopper, which is costlier also, and uh, which is costlier also, and which cannot go in many regions also. So if we compare it with our drone, then our drone is cost effective. It means it has less cost, and it is faster too, and it is more productive too. Now coming to the topic of high social impact. So by saving the lives and reducing the risk of rescues, which we'll see in details in next slide, in impacts and benefits too. By all of this, it has high social impact too. And also coming to the topic of costing in details, it has low prototype cost. It means for thinking in mind of 20% productivity, the cost is will be around 80,000 to 1 lakh. It means in 80,000 to 1 lakh, the whole drone can be made, and also it can be scalable too. But if we just go for more productiveness, for example, if we go for more than 20% productivity, then costing may increase to 1.5 lakhs. But for 20% productivity, the costing is around 80,000 to 1 lakh rupees. And why it's so low? Because we are using open sources, right? As I've discussed in feasibility, that we will be using open source softwares and also proven AI libraries which are already existing, and there is no need of new innovations of hardwares also. So that's why our prototype cost is so low, and also it's scalable for fleet operation. It means it's okay for using all of the operations, right? Now coming to the topic of impacts and benefits, the first impact for which everyone is working, which is saving the human lives. So it saves human lives by establishing the communication, by searching that by identifying that what exactly the problem is there, and what exactly help they need. For example, they need health, they need food, etc., etc. So by this, it saves human lives also, and it strengthens human disaster. It strengthens national disaster response team too. It means if earlier only people were there in the team, but nowadays by using this drone, it will strengthen the team also, and also it reduces the operation cost. If we compare it with the chopper, then also it reduces the operation cost by way too much, right? And also it enhances the rescuer safety. This is also key point, that why our drone should be used. For example, in first slide, I have shown the photo, that at that areas, what earlier used to happen, that a rescuer team used to go, and they used to go in all operations that people used to go, right? So the people used to take time also for identifying. Also at that time, they are also risking their own life. There was a chance of losing their own life too. So instead of that, what if we just use drone? Even if it's around 80,000 to 1 lakh rupees, even if we lost it, it's less than life, right? So by using our drone, it also enhances the rescuer safety too. And also by this, we can also guide the rescuer, that where do people need something. It means it can be used for, it is multi-purpose drone too. And also it promotes indigenous technology. What does it mean? That if this technology is made in India, So by using this, many people can get inspired and many people can use this technology for their betterment too, and for new ideas and projects too. And now coming to the benefits, first one is drastic reduction in response time, and also access to cutoff zones. It means places where traditional drones and chopper cannot go. At that places, our this drone can go, as it's made for remote areas only. And also it can, by establishing the communication, it can give real-time situation awareness, right? It can give real-time situation awareness, and also it lowers the operation cost. If we compare it with chopper, then it lowers the operational cost. And also 24 by 7 deployment capability. It just needs to be batteries to be charged, and by this it can be ready for deployment anytime. 24 by 7 it's possible for deployment, right? And also it increases the productivity by 20%, and also takes less time if you compare to traditional ways. And these are the research and reference that research papers that we used for preparing it, for preparing our idea, and this is our reference too. And also it was our idea and our research too. So with this, I would like